So again, this is lecture 4, congruent triangles, case 2 and case 3. I want please Zahra Jaber. Yes, Zahra Jaber. Zahra Jaber.
Yes, miss.
Please quickly, read what is written on this slide. Hurry up. These are the steps to prove congruent triangles. Start reading. Hurry up.
Okay, miss. Till 1 till 4.
To prove.
To prove two congruent triangles, there is always a special way of writing.
Number 1.
Starting sentence. Name the two triangles to be proved congruent.
Number 2.
Number 2. Elements given to be used in our proof, angles and sides. Number 3. Ending sentence. Say that the two triangles are congruent. Number 4. Listing the homologous elements corresponding parts.
Okay, thank you, Zahra. Now, please, I want Taline. Yes, Taline. Taline. Are you here, Taline? Please, can you unmute? I want you just to read, Taline.
Yes, miss.
Please, Taline, read congruent triangles 1. First case of congruent triangles. Read.
Two triangles are congruent by angle
Not
side
congruent. Taline, congruent.
Congruent.
Yes.
Congruent by ASA. If a side with two adjacent angles in the first triangle are equal to the side and its two include angles in the second triangle.
Okay, this is the first case of congruent triangles. Who said hi, miss, while Taline was reading? Who said hi, miss, while Taline was reading? Did anybody attend late?
Me.
Who are you?
Lamar Safiatin.
Lamar, okay. Karam, you attended now, and Lamar Safiaddin, you attended now. Any new attendance? Guys? Because I want to stop again. And any new attendance?
No.
Okay. So this is what Taline read was congruent triangles case 1. Now we have congruent triangles case 2, which is side angle side. I want Lamar Safiaddin to read side angle side. Yes, Lamar?
Two triangles are congruent by side angle side if two sides in their included angle in the first triangle are equal to two sides in their included in the second triangle.
Okay, these are called, they are congruent by SAS. So to prove by two congruent triangles by SAS, we should find two sides and their included angle. We cannot choose this side and this side and this angle here because this is not an included angle between these two sides. So our angle we are using in our elements to be given is an angle included between the two sides we have taken in the elements given. This is very important. And yesterday we did this application on congruent triangles by SAS. Before I move to the third case, I want to remind you again of something we talked about in our lesson congruent triangles 1. Please listen carefully to what I'm saying. If you have an isosceles triangle ABC of vertex A, who are the equal sides? The equal sides are issued from A. Who are the equal sides?
AB and AC.
Okay, so AB and AC are the equal sides. Who is the base of this triangle?
BC.
Yes, BC is the base. This is something special for an isosceles triangle. It only applies to isosceles triangles. If I draw a height from the special vertex to the base, this height at the same time will be a bisector of angle BAC. It will be a height to side BC. It will be a median issued from A to side BC. It's also a perpendicular bisector from A to BC. So this is something special about.
Miss,
Yes.
I came in late because the application had some problems. I couldn't enter.
Okay, who's
So,
this? Who's this?
Jude.
Jude, you can go to the link, not on the application, on the schedule.
Yeah, I know. You can view the recorded
Okay.
Zoom.
Okay, now continue with me, Jude. Thank you. Now we go.
Okay.
Now we go to the third case of congruent triangles, which is two triangles are congruent by side, side, side. What do we mean by side, side, side? I want, please, Carlo to read what do I mean by two triangles congruent by side, side, side. Read, Carlo, please. Carlo? Carlo, are you here?
Yes, I'm here, sorry.
Okay, no problem. Please read side, side, side. This is the third case of congruent triangles. Read.
Two triangles are congruent by side, side, side if three sides in the first triangle are equal to three sides in the second triangle SSS.
Yes, what do we mean by this, Carlo? If I have two triangles, if the three sides in the first triangle are equal to the three sides in the second triangle, then these two triangles will be congruent by SSS. If they are congruent by SSS, who can tell me what will be the homologous elements?
The angles?
Yes, yes, the three angles will be the homologous elements. Yes. Let's apply an application on this case. I want, please, I want somebody new who is Selena. Selena, I don't hear your voice very much. Yes, Selena. Selena, I think Bawab.
Miss, she's not in the Zoom.
Yes.
Sorry for yesterday. I didn't attend the live. There was no internet at home.
No worries, Adnan. I think you have watched the video, right?
Yes, I watched the video.
Okay.
Miss Cara, Selena Bawab is not in the Zoom.
Okay,
Miss, yesterday also I didn't attend because of the internet, but I watched the video.
Yes, no problem. I know that there is a problem in the net connection because of the weather. Okay, I want, please, Adnan to read because Adnan wasn't with us yesterday. Read the exercise, Adnan. The two triangles.
Okay. The two triangles are congruent by side, side, side.
No. Adnan, read the exercise. The two triangles below.
Okay, the two triangles below, KLM and OPQ, are such that KL equal OP, KM equal OQ, and LM equal PQ.
Thank you, Adnan. So we have two triangles. If you can look at the figure here, we have a purple triangle and a somehow orange triangle. We have triangle KLM and the triangle OPQ. As you can see from the marks on the figure, side KL have the same mark as side OP. This means that side KL is equal to side OP. Also, side KM has the same marks as side OQ. Here we have two dashes, here we have two dashes. So these two sides are equal. Side LM has 3 dashes and side PQ has 3 dashes. So side LM is equal to side PQ. We should prove that the two triangles KLM and OPQ are congruent. Of course, to prove two congruent triangles, I want to ask Fatima. Yes, Fatima.
Yes, Miss.
Always, Fatima, in the 3 cases that we have studied in congruent triangles, in the 3 cases, we have a specific way of writing the proof, right?
Yes.
We should always write our proof in this way. I'm going back to show you what we read before. We should always write our proof depending on those 4 steps. First, we should write the starting sentence. Then we should say the elements given in our proof. Then we write an ending sentence. And if we use the homologous elements, we write them. Now, Fatima, you are asked here to prove that the two triangles KLM and OPQ are congruent. So read the starting sentence, Fatima, please. In triangles
KLM and OPQ.
we have, what do we have? First, what about side KL? Side KL in the first triangle, Fatima, is equal to which side in the second triangle?
OP.
So we write KL is equal to OP. By given means, I have taken this from the figure. Then side KM is equal to which side, Fatima?
OQ.
So also this is by given. Side LM is equal to which side?
PQ.
Also by given. So here we have the 3 sides in the first triangle are equal to the 3 sides in the second triangle. Then the 2 triangles KLM and OPQ are congruent by SSS. Side. Yes, this is the ending sentence. So we have written the starting sentence, the elements given, and the ending sentence. Okay. Now we are done with the 3 cases of congruent triangles. Before we start solving exercises together on congruent triangles, I want to ask you all, and who knows should tell me why. If you are given, now we are working with the three cases of congruent triangles, which are ASA, SAS, and SSS. Maybe some of you are asking themselves now, how can we know which case should we apply? Are you asking yourself this question?
Yes, of the given.
Yes, bravo. To know which case should we apply in our exercise that we are solving.
We should look to the given.
Yes, we should depend on the given. Who is talking now?
Ali Basma.
Yes, Ali, thank you. So we should depend on what is given to us. We should not invent. If we are not given equal elements, we should not say that they are equal unless we are given they are equal. So as Ali said, to know which case we should use in our question that we are solving, we should not panic and say, what should we use here? Which case, ASA or SAS or SSS? We should depend on what's given to us. And in some of the questions that you will see, you might be able to apply 2 cases at the same time. You might be able to apply SSS, for example, and SAS at the same time. Here, you are free to choose any one and apply it if it can be applied, okay? So you should know which case to choose and apply. Now, which method can be used to prove the following triangles are congruent? Now I'm going to give you 2 triangles, and according to the given, you should tell me which case should we apply on the first figure. Here we have 2 triangles, ABC and ADC. Which case can we apply here to prove that these
Miss,
two
can I-
triangles are congruent? Who knows answer?
SSS.
Yes, who is saying me?
Miss Adnan.
Yes, Adnan, which case can we apply here?
Side or SSS because the given are the three sides.
Tell me which sides are equal to each other's. Name them, Adnan.
AB equal to DC,
Yes.
BC equal to AD, and AC is a common side.
Bravo, Adnan. Well done. So this tells me that we should apply, this is a common side, of course. So we should apply the SSS to prove these two triangles ABC and ADC are congruent. Well done, Adnan. In the second figure, which case can we apply according to the figure? We have two triangles, KOE and LOF. Yes.
Could I answer?
Yes. Which case can we apply here?
SSS.
SSS?
Me.
No,
Wait,
miss.
where? Miss, in which triangle?
Guys, can you listen, please? Somebody is asking in which triangles. I mean in triangle KOE and LOF. Which case can we apply to prove these two triangles are congruent? Yes?
SAS.
Who are the equal sides? KO is equal to what?
KO is equal to F.
And OL is equal to OE. Which angles are equal? Who can name the angles that are equal, the included angles?
LOF.
Miss me.
LOF.
KOELOF.
Why are these two angles equal, guys?
Common.
Because they are vertically
common
opposite
side.
angles.
Common side. Common
Yes,
side.
this is not a common, guys, listen, this is not a common angle. This is a vertically opposite angle. This angle KOE is vertically opposite with LOF. We cannot say that this is a common angle. O is a common vertex. It's not a common angle. The angles KOE and LOF are equal since they are vertically opposite angles. So, because we have vertically opposite angles, the red angles are vertically opposite, then they are congruent by SAS.
AS.
SAS, yes. So this was our lecture for this week. Now let me share another PowerPoint in which we have, guys, please mute now, in which I have exercises that we will solve together. Can you see this slide, guys?
Yes.
Okay.
Yes.
So in this, listen to me. In this PowerPoint, I'm starting now. I have exercises in which we should apply one of the three cases that we studied together, which are ASA, SAS, or SSS. Of course, we depend on the given. Now, please, I want Karam. Yes, Karam?
Yes, miss.
كيفك يا كرم?
منيح.
Okay. Karam, please start reading the question.
Given the adjacent figure, prove that two triangles ABC and DCE are congruent.
Let's look at the figure, Karam, here. This is triangle ABC, the triangle upward, and this is triangle DCE is the downward triangle, right?
Yes.
We should see, Karam, how can we prove that these two triangles are congruent? Okay?
By the given.
According to the given, what do you see in the figure? Tell me, what do you see first?
AC equals CE.
Well done, by given.
And BC equals CD.
By given. Do we have AB equal to DE, Karam?
AB equals to DE.
Do we have it?
No.
So we cannot use SSS, okay?
Okay.
Since we have Karam, two sides in the first triangle equal to two sides in the second triangle. So let's see the included angle. This angle here
Yes.
and this angle here. Are they equal to each other's?
Yes.
Why?
Because they are vertically opposite angles.
Well done. So these two triangles. So we start, read Karam, the starting sentence, please.
In triangles ABC and DCE, we have AC equals CD
CE.
and
Read Karam, read. AC equals CE by
equals
given.
CE by given,
Then
and BC equals CD given, and ACB equals DCE vertically opposite angles.
the ending sentence.
The two triangles ABC and DCE are congruent by SAS.
Thank you, Karam.
Side angle side.
Thank you. Now I want, please. Who's this?
Leah Day.
Yes, Leia. We should name the homologous elements now, Leia. After proving congruent triangles, we should see which elements are homologous elements. We have used AC and CE. We have used BC and CD, so these are not homologous elements. Which sides we didn't use, Leia?
A, B, D, E.
So these are the first homologous elements. AB is equal to DE. So the side AB is equal to side DE. We used angle ACB and angle DCE. Can you tell me this angle at vertex A is equal to which angle, Leia? CAB is equal to which angle?
Yes, I don't know.
You don't know? Leia?
Yes.
I can't hear you clearly. Your voice is very far. Leia, let me teach you how to know the equal angles in the homologous elements. If I want to know which angle is homologous with BAC, this angle, which angle is homologous with it? I go, this is side AC equal to side CE. This is side AB is equal to ED. So the angle at vertex E is equal to the angle at vertex A between the two equal sides. So angle CAB is equal to angle CED, and angle ABC is equal to angle CDE. These are the homologous elements. Any question about how did we prove congruent by SAS?
Yeah. No.
Any question, guys, before
Yes.
I continue?
No.
Okay, everything is clear?
Yes.
We should practice this exercise again to be used to how we prove congruent triangles. Now we move to our next exercise. I want, please.
Miss, I
Who's this?
Lynch
Your voice is lagging. Who's this?
Miss, it's Lynch.
Shibani.
Lynn Shibani, your voice is lagging. Try, Lynn. Read the question. Observe. Lynn Shibani, your voice is lagging. Your net is not good, okay? So I will choose now.
Can I answer?
Who's this?
Zahra.
Zahra Dia or Zahra Jaber?
No, Zahra Dia.
Zahra Dia, read the question, please. Observe.
Observe the adjacent figure well. Prove that the two triangles ABC and ACD are congruent.
So we have this figure, Zahra. We should prove that the triangle ABC is congruent with triangle ACD. First, what is the starting sentence, Zahra? Can you tell me? In triangles,
ABC and ACD.
we have, right?
Yes.
So in triangles ABC and ACD, we have. What do you have in ABC and CAD equal to each other? Start. What do you see?
AB equals to CD given.
So side AB is equal to side CD by given. Continue.
BC equals to AD given.
BC equal to AD by given.
And
What about side AC, Zahra Dia? What do we call side AC, which is found in the two triangles at the same time? What do we call side AC?
common.
Yes, AC is a common side. So the ending sentence, Zahra, triangles.
Triangles ABC and ACD are
Congruent
congruent by SSS.
So they are congruent by SSS. Now we should name the homologous elements. Yes, Ali Basma. Ali Basma.
Yes, miss.
After proving two congruent triangles by SSS, what will
Yes.
be our homologous elements?
The angles.
Can you name them, please?
Yes. ABC equals CDA
Yes.
and BAC equal CAD
Yes.
and DCA equal BCA.
Yes, so these are the homologous elements. The three angles in the first triangle will be equal to the three angles in the second triangle. This
Miss,
question, yes.
sorry, my electricity went off when I wanted to answer, but is there another question so I can answer?
Who's this?
Lean Shibani.
Lin Shibani, yes, your voice was lagging. That's why I didn't hear you clearly. That's why I told you to not to answer. Yes, I will ask you a question now. Don't worry, okay? But I want to do something
Okay.
first. Okay, let me share again the screen because I was fixing something. So we have a new question now, Leon, no problem. This is the new question we are solving now. So as you can see, the question now you see here is the same question that I gave you in the quiz on Friday. Why did I ask you this question again? Why am I asking you about this question again? Because most of you haven't written or didn't know how to write decoded properties and didn't know how to prove congruent triangles. That's why I'm solving this exercise again. Yes, Lin Shibani, start reading part A.
Give the coded properties in the following figure.
Wait, Lin. Maybe those who didn't write the coded properties in the quiz, they don't know what we mean by coded properties. The coded properties are the marked elements that we see. What do we see in the figure? Just what we see, we write. What is the first thing you see, Lean, in the figure?
Angle AEB
Before
equals,
seeing Lean, before seeing an
yes,
angle, don't see the small things before the big things. When we look at a figure, Lean, I want to teach you how to look at a figure. When we look at a figure and we need to write the coded properties, we should see the big things first, then we see the small things. What do I mean by this? The first big thing I see is, who know what is the first big thing I see?
AB is equal to BC.
No, not this.
AEB
ABCD is square.
No,
ABE is equal to
ABCD is a
33.
square.
no, they are correct, but not the first thing I should write.
AB equal BC.
No, no.
All the angles
ABCD
and
is a square.
sides.
Please look.
Common vertex.
Okay, I have listened
ABCD
to
is a
you.
square.
I have listened to you.
equals,
Listen to me. Now you can listen. The
Yes.
first thing we should write is, or the first thing I should see is A, B, C, D, because it has two equal sides and a right angle. I should write A, B, C, D is a square. Do you see a square A, B, C, D, guys?
Yes.
This shape
Yes.
in mathematics, we say it's a square. So this is the first thing I should see. This is the first coded property. A, B, C, D is a square. Then I see in it what we have. In it we have side AB is equal to BC. This is the second coded property. The third coded property is angle ABC is marked 90. So I write angle ABC is equal to 90 degrees. I should see this. Now I look here, I see a triangle AEB. I can say AEB is right at E, or I can say angle AEB is equal to 90 degrees. Angle ABE is equal to 30 degrees. Angle BFC is equal to 90 degrees. We do not have any other coded property. I only say the things that are marked. Here I see a right angle. I say, what is the right angle? AEB equal 90 degrees. EBA 30 degrees. Side AB is equal to side BC. Angle ABC is 90. BFC is 90. So these are the coded properties. I have written them here. ABCD is a square, AB equal BC, angle AEB is 90 degrees, angle ABC is 90 degrees, angle BFC is 90 degrees, and angle EBA is 30 degrees. Got the coded properties, guys, or you have any question about, because this question you will always be asked about it.
Okay. Miss, but who didn't write that ABCD is a square, he got a minus in the test?
No, I didn't give a minus this time, but next time I will.
Okay.
Okay?
Yes.
Now we have part B. In
Miss,
part
when the
B,
meeting ends, do we rejoin?
No. Our time is over. So let's leave this question for tomorrow. And we are done today. Thank you for joining, guys. Meet you tomorrow. Okay?
Welcome, Miss. Bye, Miss.